a minimum point, so 3 is yes.
Yeah. Sure.
So that's why the answer is D, 1 and 3 only. All right. Number 82, it's that second fundamental theorem of calculus thing. If f prime of x is equal to f of x, f is a continuous function, and f prime of x is equal to f of x. That means, from 1 to 3, f of 2x dx, it's really just this. What we do is we've got some function, the inside function is 2x. So the derivative of the inside function is a 2. In order to complete this, we would need a 2 here and a 1/2 out here. So we've got 1/2 of our function, f of x, from 1 to 3. But inside it's the 2x. So we just copy this down to here, and we needed that extra 1/2 out front, but we just go from 1 to 3. And you're plugging in a 3 first, so f of 2 times 3 minus f of 2 times 1. You got a 1/2 of f of 6 minus f of 2. And that's where you get the e if you do the distributive property.
I did that in the second one. I just redid it.
Okay, some of you got that.
That's retarded.
All right, the limit of that thing. What's one way to do 83? One way to do the limit. X squared minus a squared over x to the 4th minus a to the 4th. Factor, okay? Factor the top. It's difference of squares. X plus a, x minus a.
Don't do that.
What?
Don't do that. Don't do it, though. It saves work.
The
Don't
bottom. Why? Shorter.
Because you just do the
I'm gonna
bottom.
show you the.
You just do the bottom.
Yeah, just do the bottom.
We parked them out.
Number 83.
Yeah. X squared minus a squared over x squared plus a squared. Yes, you realize this is the same as this. You get. We did this because direct substitution did not work. If you plugged in an a, you'd get a 0 at the bottom. So by factoring, you get this. Now if we plug in an a in place of x, we get 1 over 2a squared. Okay. 84 gets to use the population is d times g to the x, which if a population, it's our PERT formula. In calculus in the book in chapter 6, it turned out to be the Keck formula. If a population doubles, really this is just, here's our population after so much amount of time, here's our initial population. It says our population is going to double, so p is going to turn into 2p. We divide both sides by p, we get e to the kt is equal to 2. So your population goes from p to 2p. If I now wanted to solve, what's the value of k? Natural log of both sides. Natural log of 2 is equal to kt divided by t. And doubles every 10 years. Oh, this was 10. So natural log of 2 divided by 10. Okay, the formula we're using in Algebra 1 is y equals b times g to the x. Initial population is p. Our growth rate, we don't know the growth rate. It's an e. We use e in calculus. This was a number of years, 10, but yeah, we had this extra k thing in there. Think of PERT. But PERT becomes kt. So it's instead of rt, it's kt. K was our factor. We get a 0.069. Any other ones? We are about out of time.
Somebody does a lot.
Number, what, 86 was a good one? That, I did it all by hand, but you had a thing. You revolve that around the whatever axes. Anything you want to know before? What?
Was 85 the sigma?
I figured it out already.
Something here,
I'll do this.
85 trapezoidal approximation. Really, you could have graphed it and add up all your little things. Get some from 2 to 5 you had a trapezoid, okay? The distance across the bottom was what? We're going from 2 to 5.
There's 3.
Okay, and they gave you y values.